An inverted index is another data structure that stores a list of terms. For each term, there is another list that stores document IDs that contain those terms. These document IDs are sorted for faster retrieval. It uses the same storage space as a traditional index that most of you are familiar with. The list of terms act as the keys of the dictionary, and the list of documents, also called postings, are the values corresponding to those keys. The postings are of variable sizes and support new entries at runtime. Moreover, the dictionary that is created in the end is sorted. This allows a binary search to be performed on it. Before we go over the creation of the inverted index, we need to perform some pre-processing steps to prepare the documents. The first step in pre-processing is that we gather the documents that need to be indexed. Then we tokenize these documents. Tokenization is the process of breaking the streams of text into individual words or symbols. In this step, the sentences are converted into a list of words. The third step is that we perform text normalization. For example, we may lowercase of the entire corpus for consistency. We may remove stop words. Stop words are the common terms that provide no meaningful information about the content of the document. They include is, are, the, a, of, and more. Side note, Google does not remove stop words in their retrieval algorithms. We can also perform stemming, which is a process that converts a word into its root form. For example, we may change the word authorization to authorize. This may result in grammatical errors in the document, but it will not impact the information contained in those sentences. After these pre-processing steps, we can finally create the inverted index. The first step is creating the inverted index to create a list using the document IDs and the terms. We then sort the list based on the terms. The second step is to sort the document IDs. The next step is to merge multiple term entries in a single document. The fourth step is to split the list into dictionaries such that the terms are the keys and the postings are represented and stored as a sorted list of values. The fifth step is to add information about the document frequency. This indicates the number of documents containing a particular term. This is added next to the term in the dictionary. Inverted indexes save a lot of storage space. For example, if we have 1 million documents and each document is 1,000 words, suppose the total vocabulary size is 500,000. The inverted index will have 1 billion entries. In the case of querying for retrieval of information, suppose we have to retrieve documents that contain terms diabetes and medicines. For this, we would need to locate all the postings that contain the term diabetes and all the postings that contain the term medicines. Once we have two postings, we would need to merge them and then retrieve the final set of documents. For more details on the complexity of the merging operation, please refer to the companion article of this lecture. Another concept related to querying is the phrase queries. Suppose you need to retrieve documents that contain the term machine learning. Consider the following sentence. The packaging machine was performing smoothly, although he had a bit of a learning curve to operate it. This sentence does not contain the term machine learning, but the document containing this sentence should not be retrieved. We need to add more information in addition to the term and the document IDs. The phrase queries, like the search term machine learning, requires that you store the position of the words to avoid false positives to be retrieved in the result. One solution to this problem can be save all possible combination of the terms. But this solution is not scalable for larger corpus. A better solution is to save the position of the words in the postings. You can also specify the number of words that can exist between the two terms that you've provided for retrieval of the documents. This modification to the phrase queries is known as proximity query. To process a query containing a phrase, we will first extract the entries for each distinct term in the inverted index. We will then merge the document and position lists to get all the positions. We will then check the position list to see which document match the criteria provided in the query and retrieve those documents as a result. This is the general method of proximity searches. Having a positional index in the inverted index increases the storage requirements of the index, but it is now used because of the power and usefulness of the phrase in proximity queries. These indexes are double, or sometimes even more in size as opposed to the indexes without the information for the position of the terms.